All right, guys, I see everyone has said hello over in the Zoom group chat, so I know we're all logged in there. So that is your microphone. So if you have any questions, you can use that to ask them. And we've all gone to nearpod.com at this point. When you get there, make sure you type in that code if you haven't already. After you do that, you're going to get a screen that asks to put in your name, and you should have done that as well. I'm going to check on that, and I see Kurt, Ronnie, and Sue are all in there. Sounds great. All right, guys, so you can see our first slide has our objectives for today on it. We are going to compare and contrast solar and lunar eclipses, and you should be able to do that by the end of this lesson. And you should also be able to explain the causes of high and low tides. Okay. So first we're going to talk about eclipses. So there are two main types. There's solar and lunar. And they both have to do with the sun, the moon, and the earth. But the difference between them is the movement of the sun or the moon or the earth. So they're going to move in different orders depending on the type of eclipse. And they're either going to block or alter light in some way. So your first question you can see up there on your screen, and it says, what do you think is the difference between a lunar and a solar eclipse? So go ahead and take a try at answering that question on your screen. You should have a text box. You should be able to type your answer in there. When you're finished typing, you should get a blue submit box down in the bottom that you can click on. Okay, so Kurt's answer is that the difference is the position of the Earth, the Sun, and the Moon. Sounds good. Ronnie and Sue, when you're done typing, make sure you click that blue submit button. Okay, Sue says lunar is an eclipse of the moon, while solar is an eclipse of the sun. Okay. And Ronnie said a solar eclipse is closer to the sun and a lunar is farther. Okay. Alrighty, guys. So first, let's take a look at a picture of what's going on during a lunar eclipse. So in that top left-hand corner of this diagram, you can see the sun. And during a lunar eclipse, the Earth is actually casting a shadow on the moon. So you can see there's actually two different parts to that shadow. There is the umbra, which is the darkest part of the Earth's shadow. And the atmosphere actually causes light to bend. And when that happens, it slows down and causes the moon to change a different color. But it's just the color of light just changing as it goes through that atmosphere. So during a lunar eclipse, sometimes you can see the moon is actually a very bright red color. When it is in the penumbra, you'll either see it's partially red or it's totally dark and you can't see it at all. So that's the difference between our umbra, our darkest part of our shadow, and our penumbra. It's only that red color when it's in that umbra shadow of the Earth. So our lunar eclipse only occurs during a full moon, and it happens when that moon moves through the shadow of Earth. It takes about an hour for that moon to become totally eclipsed. So for it to become totally red, that process takes about an hour. And remember the difference between our umbra and our penumbra. Our umbra is the region of total shadow, so that's when it's red. And the penumbra is when the sunlight is dimmed but not extinguished. Our solar eclipse is similar because it involves the sun and the moon and the earth. But in this case, the moon, instead of being on this side, on that right side, like it was during our lunar eclipse, the moon is in between the sun and the earth. So it's actually here on Earth that we see the shadow of the moon. And the shadow of the moon has two parts, just like the shadow of the Earth had two parts in that lunar eclipse. And they're still called the umbra and the penumbra. So the umbra is still that darkest part. If you are in that part of the Earth's, or that part of the moon's shadow, that's the umbra, you would see total darkness, with the exception of a bright corona, it's called. So that corona is actually a circle that happens that goes around the moon. And if you're in the umbra part of the shadow, you're only seeing a partial eclipse. So you would see part of the moon and part of the sun at the same time. You would see part of that moon covering the sun, but the sun would not be a circle shape. It would look like a crescent, just like the moon does sometimes. So again, we've got that umbra and the penumbra. So main things about our solar eclipse that happens when our moon's in between the earth and the sun. The moon is small, so it only casts a small shadow. It does not cover the whole earth. And that darkness only lasts a few minutes during a solar eclipse. And the places that are in the umbra are going to have a total solar eclipse. And if you're just in the penumbra, you're going to have a partial solar eclipse. So what you guys see now is a collaborate board. So I'd like you guys to take a minute, see if you can find an image of what a lunar or a solar eclipse looks like from Earth. So try to find a picture that someone has taken of what a lunar or a solar eclipse looks like. To find that, if you guys look in that bottom right-hand corner, you have that blue square, and it has little mountains on it and a tiny little dot. If you click on that, a box will come up that you can use to search Google Images. So on Google Images, I'd like you to use that to try and find a picture of a lunar and or a solar eclipse. So you can pick which one. If you have time to do both, you can. So after you type it into that Google box, either type lunar eclipse or solar eclipse into that Google search bar. And then try to find, if you are looking up lunar eclipse, you're going to look for a picture of a red moon. If you're looking up solar eclipse, it's going to look kind of black, that white circle around it. So I'm going to share one for you guys, just so you can see it. Kurt's got a picture of a solar eclipse up there. I put one up for you guys to see so you can see one of each. Looks like Sue found one of each. Sue's definitely got that solar eclipse on the left. So Ronnie, when you find one, make sure you click on that blue post button in the right-hand corner, the bottom. Looks like Ronnie found one. Yeah, that one's pretty cool. Looks like that's in Greece. Nice job, guys. These are some pretty cool pictures. Oops, someone find another one? Yep, Sue found another one of a lunar eclipse. You can see that one too. Looks good, guys. Okay. All right, so now that we've gone through our diagrams and you've seen some of the things that are, oh, hang on a second.